Yeah, welcome you all for the DC Machines and Transformers Laboratory, and through this short video lecture series, now we will give the introduction for the no load and load test on self-excited DC Shunt Generator, right? So in this we are going to perform the two characteristics, that is to study the voltage building up characteristics of a self-excited DC shunt generator. So that means how the voltage was generated up to the rated level, from zero level voltage to rated voltage, how it generated, that we are going to verify. And the second is to obtain and analyze the load characteristics of the given self-excited DC shunt generator alone. So we are not going to deal with and without speed control, so that is why mistake is given, right? And once you enter into the laboratory, you need to take the nameplate detail of the motor as well as generator, right? So for your information, this test will be carried out in the table number 6, right? So once you enter into the laboratory, you directly go to the table number 6 and you note down the motor nameplate detail as well as generator nameplate detail directly from the nameplate sheets, right? And then you do the fuse design and armature rheostat design, and the same way you can go for the generator field ammeter design and line current design and voltmeter design. Everything you need to design as per the previous video lecture explanations, video class explanations, so that you need to summarize here in the selection of apparatuses, right? And then you need to get this initial from the faculty, and then you can give the indent slip to this type of slip to the technician, and he will provide whatever the required components you requested, right? So after that you need to do for the connections. While doing the connections, so once again your connection part is somewhere starts from this 2 points, right? And this point you need to consider as positive, and that means the remaining things will be connected internally. The positive terminal should be connected to the L point of the 3-point starter, that is line point of this 3-point starter, and F point of the 3-point starter should be connected to the fixed end of the field rheostat, and variable end of the field rheostat should be connected to the field terminal coil Z, and then other side of the field coil Z should be connected to the negative of the supply, right? And now the A point, armature point of the starter, should be connected to the A terminal of the armature, and AA terminal is connected to the ZZ terminal. So here you need to connect, so that this part, prime mover side, this part we will call it as prime mover of this particular generator, who will provide the mechanical input to the generator. So this part will be completed, and now you can move to the generator part. In the same way, the A terminal of the generator should be connected to the one side of the SPST switch. This switch will be marked as SPST switch, SPST, single pole single throw switch, right? So now your A terminal should be connected in the one side of the single pole single throw switch, and the other side of the single pole single throw switch will be connected to the rheostat's fixed end, right? The variable end is connected to the Z terminal, and ZZ terminal is connected to the A terminal of positive A terminal of the ammeter, and negative ammeter side will be connected to the armature, another terminal, AA terminal, right? So now across the same SPST you need to connect the voltmeter, and also you from the negative of the ammeter you need to connect the negative of the voltmeter. Now up to this part your connections are over. Now the positive of the voltmeter is connected to the input of the DPST switch, and negative is connected to the another input of the DPST switch. The output of the DPST switch is connected via the fuse, and it is connected to the positive of ammeter, and negative of the ammeter is connected to the one end of the load, resistive load, and the other end of the resistive load will be connected to the another output of the DPST switch. Now by this time you can complete the connections for the particular experiment. Now you can do the procedures so that you can start the machines. So I will remove all these markings. Right, now first you need to do the no load characteristics. That means for that there is a precautions. Your DPST should be in the open condition. Prime mover field rheostat should be in the minimum resistance position, that you need to note down. So this should be in minimum rheostat position. At the same time, arm generator field rheostat should be in the maximum position. So these are the two conditions you need to check. And now for the no load test, DPST, so you need to give the connections as per the circuit diagram. Prime mover side DPST should be closed and this DPST should be closed. Now using the 3-point starter, you can start the motor prime mover, that is prime mover, by adjusting the 3-point starter. The prime mover speed, the motor order speed, prime mover speed is nothing but motor speed. Motor speed you need to brought to the level of generator rated speed. Suppose the generator rated speed is 1450, right? And you need to operate the motor to the rated speed of 1450. So likewise you need to adjust this motor speed by adjusting this field rheostats, right? So this is what given here. The prime mover speed is brought to the level of generator's rated speed by adjusting the motor field rheostat. Now the generator terminal voltage is recorded as residual voltage. Now this SPST is open for your information and no field coil is connected across the generator, but even though that time it generates some amount of small voltage, and that is the voltage you need to mark here. So in the characteristics curve, when your IF is 0, so this is called IF, field current is 0 in the generator, it generates some amount of voltage. So that means this voltage we will call it as residual voltage. Your field current is 0, but at the same time it generates some amount of EG, generated EMF, right? So this voltage you will mark as residual voltage, that you need to record, and then close this SPST switch. Right, now the field current is increased by adjusting the field rheostats, and you can take the generator terminal voltage, field current value at the various levels, and this can be continued till the generator output voltage reaches 120% of rated voltage. Suppose the output voltage is 250, means you can go for up to 1.2. So 1.2 of 25, how much? It is around 120 and 60 and 240 and 60, around 300. So up to 300 volts you can generate, so that you can realize this saturation part in the characteristics. Otherwise your graph will be stopped here, right? You need to increase the IF such that your generator output voltage gets saturated, right? So that should be recorded. The same is repeated for some other speed of the prime mover, right? So by the time you will get one more characteristics like this. So both should be recorded. This is with respect to the no load test, right? So now with respect to the load test, now to conduct the load test, you are going to utilize the same circuit diagram. So in that case you need to close the DPST switch and start the prime mover with the 3-point starter, adjust the motor field rheostat such that the motor operates at the generator rated speed. So up to this level of procedure is same with respect to the no load test. Now after that they close this SPST switch and increase the field current so that this voltmeter reads rated output voltage. Now at this point you close this DPST switch and increase the resistive load value such that this meter reads in a step-by-step manner. This should be repeated in a step-by-step manner such that this meter reads the rated current, 120% of rated current. So for each IR value, you need to record this I and V voltages that should be recorded in this table. So your load current IL should be recorded here. For a particular IL value, what is the corresponding field current IF you need to record, and what is the terminal voltage. So remaining thing you can calculate, and the first 3 columns you need to record for various readings, and the final reading may be 120% of your rated current, right? In this case also you need to measure the armature resistance, and for that you need to do a separate experiment. You just cross check with the speed control of DC shunt motor, right? The same way you can measure the armature resistance, right? And remaining things are calculations. If you have any doubt, you can clarify with us. Thank you. Thanks for watching.